In today's video, you are going to be learning about lessons 4.10 and 4.11. 4.10 deals with the logarithm laws, which you are required to know by heart by the end of this unit. Luckily for you, they are very similar to the exponent laws that you should already know. Now, before we begin, we need to talk about what imaginary number is in the base's position if there is no number there. So you guys have learned in the past that if you had a square root symbol, there's always been this an imaginary 2 there. Similarly, if you have any variable that doesn't have a number in front, there's always an imaginary 1. Same thing with an exponent. If there is no exponent, there's always an imaginary 1. Well, for logs, if there is no number in the base position, remember this is the general form of what a log looks like. If there is no number down in the base, like if it just says the log of 100, that imaginary base is 10. Okay, so if there is no base there, there's an imaginary 10. And remember, to do logs, it's always the base to what power equals this number next to the log. So the answer to this would be 2, because 10 squared is 100. Okay, so here are the rules. You already know the exponent version of each of these rules. We have product, which remember means multiplication, in case you forgot. Quotient is division. And then power is when you have 2 exponents. I should say 2 or more, but 2 exponents. Okay, so the exponent version, when you are multiplying with common bases, so for example, b to the x times b to the y, so they both have a base of b, you add the exponents to get a single base of b. For quotient, I will stick with b. If you had b to the x divided by b to the y, you will recall you subtract the exponents to get a single base of b. And then if you had 2 exponents, so b to the x to the y, so you have 2 powers, you multiplied. Same idea for the logarithm versions, except for you're not going to have bases with exponents, you're going to have logarithms. So if you had the log of some base b, but then in parentheses you had x times y, so you have 2 quantities that you're multiplying together, you can split your 2 quantities, x and y, up into 2 logs using addition. So you will notice, and they both have to have the same base, just like over here, you split, or you combined them into the same base, but they ended up having the same base of b. So they are having, this is a b, not a 6, but you're going to split them up using addition if you were multiplying 2 things together. Same thing for division. If you had some log base b of x divided by y, you can split that up into 2 logs using subtraction. So that's log base b of x minus log base b of y. And then here, this is a little different. You're not going to split it up into 2 logs, but you are going to have something like this. We have log base b of x raised to the y. So how to deal with an exponent in a log is that it drops down to the front to be multiplied. So notice we're still using multiplication when you have an exponent. So it's going to look like this. You're going to stick the y out in front. It's going to be y times the log base b of x. So the exponent moved down to the front to be multiplied with the log, which this one you're going to use a ton with your word problems when you're trying to solve if the exponent is what is missing, which last unit, or the first half of this unit, the last flip book, I told you guys that you didn't know how to solve for a missing exponent yet, so you either had to do common bases, and if you couldn't do common bases, I told you to just use the calculator's solve function, or you could have graphed them and found where they crossed. But now you're going to learn in the next lesson, you're actually going to practice this last rule. It is very important, probably the most important one. Okay, so we're just going to do a little bit of manipulation here with these laws that you have to have memorized. to solve, and most of these are multiple choice, but so exercise 1, which of the following is equal to? So when they say equal to, you're basically going to rewrite this and try to, like, you know, using your laws, simplify it or expand it, or find something it's equivalent to. So if you notice right here, there's an imaginary multiplication symbol between 9 and x. Well, if you look up at your product law, you can split up two things that are being multiplied in a log into two different logs using addition. So I'm going to rewrite this as log base 3 of 9 plus log base 3 of x. Now this one, because there's an x in there, you can't break him down any further. So your answer is definitely going to have log base 3 of x in it, which all of them except for choice 4, so we know it's not choice 4. But this guy has no variables, which means I can come up with an answer. Remember, you take the base and you're raising it to some power to get 9. Well, you guys know that, I'll do little like scratch work over here, 3 squared is 9. So the answer to this first part, log base 3 of 9, is 2, because 3 to the second power is 9. So that turns into 2. This stays log base 3 of x. So my answer is choice 3. Exercise 2, you will notice, deals with division. We have a single log. Notice it's missing a base, so you can put your little imaginary 10 there. The base is 10. We have a single log with two things being divided. So we're going to split that up into 2 logs, and if it's division, you do subtraction. So I can rewrite this as log base 10 of x squared minus log base 10 of 1,000. Now again, this guy has a variable in it, so his answer is going to have x in it. I'm not really going to be able to do much more to this. This guy, though, the second one, does not have a variable, so I can find an answer. I can evaluate it. I can get a number. So you got to ask yourself, 10 to the what power is 1,000? Well, 10 to the third power is 1,000, so the log base 10 of 1,000 is 3. Now, before I write that down, though, the front, I can simplify it a little further because I can use my last law, which is the power law, because there's an exponent in my log. To deal with exponents, if you'll recall over here, the exponent simply drops down to be multiplied out in front by the log. So this 2 is going to drop down to be in front. So I can rewrite this as 2 times the log base 10 of x, which this is useful because now I don't have exponents anymore. I just have multiplication, minus, and we said this guy turned into 3 because 10 to the third is 1,000. And that's your final answer. You can't simplify this anymore because we don't know what x is. And we don't know what it equals. Like there's no, like if they told us this whole thing equals 100, then yes, we could go on and solve for x, but you're just simplifying. Exercise 3, they tell you that you can call the log of 3 a and the log of 2 b. So they want to know, out of these choices, which of the following correctly expresses the value of the log of 12? So we want to be able to rewrite 12 using multiplication, because we have a product rule with multiplication, using 3 and 2. So 3 times 2 is 6, not 12. But you should realize there's 2 ways to write this. You ready? You could break 12 into 3 times 2 times 2, or that's otherwise known as the log of 3 times 2 squared. Either way, you're going to get the same answer, and I'll show you that you will. So when you have multiple things being multiplied, that's the product rule, we can split this up using addition. So this is the log of 3 plus the log of 2 plus the log of 2. Well, we know what the log of 3 equals. It told us up here that the log of 3 equals a. So I can rewrite the log of 3 as just a. The log of 2 is b. And so both of these are b's. Well, a plus 2 b's is choice 4. You could also do it this way. you can break this up using your product rule, using addition. So the log of 3 plus the log of 2 squared. And then you have to use your power rule and drop the 2 in the exponents down to the front. So this becomes the log of 3 plus 2 times the log of 2. Well, now if you replace the log of 3 and the log of 2 with what they told us they're equal to, this becomes a plus 2 times b, which is the same thing I got over here. Okay, last one deals with, you definitely hopefully see the division, but you also will see some exponents. And you might only first be seeing the 5, but there is an exponent with the x as well. It's just written in root form, and you're going to convert it back to fractional form. So first, let's break this up using our quotient rule. This is the log base 2 of the square root of x minus the log base 2 of y to the 5th. Now, whenever you see a root, you want to rewrite it using your fractional rules, your fractional exponents. So remember, the power, if there isn't one, is an imaginary 1, and the root, if there isn't one, is an imaginary 2. So this can be written as log base 2 of x to the 1/2 power minus log base 2 of y to the 5th. And then the last thing we have to do to simplify this, to expand it out, is to use our power rule where the exponent drops down in front of the log. So there's 2 exponents and they go in front of their own logs. So this becomes 1/2 times the log base 2 of x minus 5 times the log base 2 of y, which is choice 3. So when you are doing these questions, you are using your rules to simplify or rewrite your logs, and you will see why in the future, because sometimes it is easier to work with logs when we can break them apart, because then we can use our calculator to help us solve these. Okay, so moving on to lesson 4.11. This is where you are going to notice, once we get there, we're going to do a few examples in the beginning, but towards the bottom, you're going to notice that formula. We've worked with it in the last flip book. So this deals with the third logarithm law, which was the power one. This one, I told you, is probably the most important one. It's where if there's an exponent, it drops down to the front of the log to be multiplied with it. It is the most important one because it allows us, if you want to write this down, it allows us to solve when the exponent is our variable. If the variable, it's usually x, or sometimes, a lot of times down here, it'll be t because it's time. When the exponent is what is missing, or the variable. A lot of times it's x or t, but when that is what is missing, you haven't been able to solve for that yet. You either had to use the common bases method or you had to use the calculator. We're still going to use the calculator because we can't do logs in our head for a lot of them. You guys know there's only certain numbers that when you square them, like 2 squared is 4, 3 squared is 9. You will never be able to square a number in your head to get 5. There is a number that when you square it, it is 5, but it's really ugly. So that's why we use the calculator to help us. Just like there's a number, when you square it, you will get 6, you will get 7, you will get 8. 9 is easy, that's 3. 3 squared is 9. You can get 10, you can get 11, you can get any number, but they're not easy to do in our head. So that's why we're definitely going to need our calculators. So we are going to practice solving these. Look at the first one and notice this is a huge hint on your regents on any test. If they tell you what you should be rounding to, you should be getting ugly numbers with decimals. It's not going to be pretty. So look at this first one. They want to know, what could you raise 5 to get 18? Well, please use your common sense, guys. 5 to the first is 5. 5 squared is 25. So that means you don't have to understand, you don't have to do this, but I'm just trying to have you use your common sense. 18 is in between here, correct? So my exponent is going to be somewhere between 1 and 2. It's probably going to be closer to 2 because 18 is closer to 25 than it is 5. So let's take a look at how we would do this. Well, we know that we can get an exponent to drop down to be multiplied if there's a log there. Well, I don't see a log on either side. But do you agree that For example, in the past, if you wanted to solve for a variable, you could like multiply both sides by 2. And that was a legal math move as long as you multiplied both sides by 2. Well, same thing. If I add a log to both sides, that is a legal math move. Now both sides have a log, and I know how to use my power rule for logs, how to get an exponent to drop down. Now that there's a log on both sides, this x can drop down to the front. So I can rewrite it as x times the log of 5 equals the log of 18. Now x is no longer in the exponent spot, so I can just solve this like I always have. You cannot split up the 5 from the log. Okay, the 5 and the 18 are each attached to the log, so they have to stay together. So to get x alone, to get rid of the log of 5, it's multiplied, so I'm going to divide the log of 5 over to the other side, and this is where you need your calculator. You can't do in your head 10, remember this is an imaginary 10 base 10, 10 to some power is 18. You're not going to be able to do that in your head because it's not easy. Same thing here, 10 to some power is 5. Your calculator can do it quicker, and it's going to divide those out. So literally on your calculator, you just type the log of 18 divided by the log of 5. It'll spit out some number, and you got to round to the nearest hundredth. It's 1.80. Make sure you put that 0 there because you have to tell me you know that hundredth means 2 decimals. Okay, the next one, x is in the exponent spot. It's saying 4 to what power? Oh, and by the way, notice I did get a number between 1 and 2. It was closer to 2. So back to B. 4 to some power is 100. Well, it's not going to be a pretty number because 4 to some power is not going to give you an even 100. It's going to be some decimal. So to do this, we want to drop the x out of the exponent spot. So I'm going to add a log to both sides. And remember, it's an imaginary base of 10. If you want to write the 10 in there, you can. But your calculator, if you don't put a base in, it will know it's 10. Drop the exponent down to the front. And now get it alone. To get it alone, it is multiplied with the x. So I'm going to divide the log of 4 over to the other side. And you simply type it in your calculator. Log of 100 divided by the log of 4 turns out to be 3.32. And the last one, again, add log to both sides so that the exponent will drop down. So it turns out to be x times log base 10 of 2 equals log of 1,560, base 10 again. Divide the log of 2 over. Type it in your calculator. It turns out to be 10.61. So there's just a quick kind of preview of how to solve when your variable is your exponent, which brings us to why you need to know how to do that. You will recall this formula should look a lot like our A equals P times 1 plus R to the T. It is the exact same formula except for they used Q instead of A and P. So Q sub 0 represents the amount, like the starting amount. This is your initial or starting amount, which is what it represented, P represented in our interest formula. And then Q of T is the amount, the ending amount that you're trying to get. So this is the ending amount. Okay, so in the first question, the only question, it says, a biologist is modeling the population of bats on a tropical island. When he first starts observing, so that's your starting number, so this is your Q sub 0. That's your starting amount is 104 bats. The rate is 3%. So P is actually the rate this time. It's your fixed percentage in decimal form. We've already talked about this. You don't ever really work with a percent. You have to turn it into a decimal. So the first thing I'm going to do here, I'm not even going to read what part A wants because I'm going to first convert and know that 3% is 0.03. Part A just wants us to write our equation using those numbers. So I don't know, I'm trying to find, they want me to use B of T instead of Q of T, because B for bats. My starting population was 104, so I'm going to plug that in for my b sub 0. 1 plus 0.03 is 1.03, all to the t. Now I'm going to use this equation to figure out how many years, so I'm solving for t, will it take to get to 200. So this is my ending amount, right? I want to know when will I get to 200. So 200 goes in for b of t equals 104 times 1.03 to the t. Notice my exponent is what I'm solving for. Well, you're going to have to use your log power rule. Before you add logs to both sides, you want to move anything over to the other side that you can that is not directly attached to the exponent. Well, you'll notice this 104 is not attached to the exponent. It's actually attached with multiplication to the 1.03 to the t. So I'm going to divide the 104 over to the other side. Now, this is not a pretty number. Leave it as a fraction. I just reduced it. It reduces to 25 over 13 equals 1.03 to the t. Now, I can log both sides so that the t will drop down to the front. So I'm going to rewrite this as the log of 25/13 equals the log of 1.03 to the t. Now that I logged both sides, I can have the t drop down to the front. So this becomes the log of 25/13 equals t times the log of 1.03. Now that t is out of the exponent spot, I can divide the log of 1.03 over to the other side. And I'm going to just use my calculator and type in exactly what I have written on my paper. I'm going to type log of 25 over 13, close your parentheses, divided by the log of 1.03. It says round to the nearest year. It turns out to be 22 years if I round it. And that is it for this lesson. So when your missing variable that you're trying to solve for is in the exponent spot, you're going to end up having to log both sides so that it'll drop down in front and then divide the log over to the other side. And that is it for lesson 4.11.